Welcome to our quite exclusive talk, Migrating Deployment Processes and Continuous Integration at SAP SE.
To a future-proof design using SLES 12, Chef, GitHub, OBS, and KIWI.
And some other tools. So let's start, I think. First, we have a short introduction. And at first, we want to introduce the company we are working for. A Germany located company founded in 2004. But we are operating both nationally and internationally. We've got meanwhile around 100 employees. And we are totally vendor independent, be it in hardware, be it in software. But despite all that, we are mainly focusing on SUSE, and we are a SUSE consulting and training partner. Our business focus is in consulting, support, and training, development, operations, or in short terms, all solutions you can imagine around Linux and open source software.
Yeah, as you can see on the graphic, we are heavily into cloud computing. We support all major OpenStack enterprise solutions that are out there. We're also into monitoring, configuration management, systems management, all the platforms, all the vendors you can imagine. Also, we are independent in what kind of virtualization we use. In general, Xen, KVM, everything that is supported on the Linux operation systems and SLES. And also, we are independent on which operating system we use. This talk is mainly about SUSE. That's because we're at the SUSECon.
Surely it is.
Yeah,
so now let us introduce ourselves.
I'm KIWI. I'm Linux consultant and trainer at B1 Systems. I work for 1.5 years for B1 Systems, and mainly for the same time I work at SAP.
Yeah, I'm Florian Winkler, also Linux consultant and trainer at B1 Systems. I'm there since 2014 and working in the SAP environment, cloud environment, since about 2 years now. And the project we want to show you today is a close collaboration between, of course, the SAP, as we are talking about two of the oldest and biggest clouds there on SAP. One is the SAS Cloud, and the other one is the HANA Enterprise Cloud, or short HEC. And as you can see, there are more companies involved, like us at B1.
Actually, B1 has a managed service contract to operate the HANA Enterprise Cloud for the SAP for quite a few years.
Yeah.
So now I'm going to tell you what we are going to tell you today. As you see, it's quite a lot, so we have to speed up a little bit. So first we'll tell you what was our motivation for re-innovating the deployment as the two SAP clouds. Then we'll tell you what software we used, tell you a little bit about the global management portal we are using at the SAP. And then we show you the single steps that we did, redefining deployment, introducing configuration management and a good version control system, and also our CI and CA workflow that we deployed there. And at the end, we tell you how we integrated this together at the infrastructure we found at SAP. Yeah.
So, talking about motivation and the goals we wanted to achieve. We started this project around a year ago when SLES 12 SP1 was just at the doorstep or just released.
And you all know that if you have a SUSE product, you always have to wait for SP1 to use it in production, so we kind of waited for that.
Yeah, kind of true, and as you all might know, there were several changes compared to SLES 11, like the introduction of systemd, Wicket, and stuff like that, so we really wanted to make a clear cut and also redesign our deployment process, which has historically grown since the SAS Cloud is about 10 years old now, and it was much smaller when it started, of course. Clouds grow, as you might know. So yeah, the whole deployment processes and the scripts we are using grew bigger and bigger, so we really wanted to reinvent it and put it on a more modern approach and a more modern base. And also, we had no real configuration management so far, and we also wanted to take the chance to introduce that.
Yeah, and I also wanted to do the fancy DevOps shit that's kind of the state of the art now. So
yeah, well, it's not only fancy, it's a really good workflow and mindset, I think. And also, HEC and SAS once have been more or less one cloud. Then they split it off, and we wanted to regain a new common base and get them both more close together again.
Yeah, now I'll tell you a little bit what software we used. Of course, SUSE Linux Enterprise Server 12. Then we're making heavily use of the Open Build service that was already there at the SAP deployed. SAP is actually building a lot of RPM packages for their custom software, and also they maintain some legacy stuff with it. We're also building KIWI images in the Open Build service and Docker images. And yeah, we're also using Jenkins, of course, for CI infrastructure. We use the GitHub Enterprise that was also already deployed at the SAP. That's why we choose that and didn't go for open source solution. And then we're making use of the whole Chef stack, because yeah, the configuration management that we introduced is Chef. Yeah.
Don't forget to mention Docker.
Oh, of course,
it's important for us.
It's also included
for
in the
testing.
Yeah, in the workflow.
So talking about cloud environments, I want to give you a short overview of the landscape. I hope you can read it. First, we've got the admin, that is us, and much more people that are working as admins. Then we've got the so-called GMP Global Management Portal, which we will introduce on the next slide, I guess.
Yeah.
And this is more or less our central orchestration platform and our web interface to do everything.
We'll come to that later.
Yeah. Then we've got the split HAG and SAS, which run into the same database backend. And then the next entity would be the landscapes, which is more or less a mapping to all the data centers around the world, from Sydney, North America, Europe,
Moscow,
Asia, yeah,
Australia,
really all over the world, and that's the next entity. Then it comes to customers. They have control, or they are using different resource pools, which is the next entity. It's more an organizational one for us to keep separation between customers and stuff like that. The more interesting thing is that the resource pools divide into hardware and VM pools. So we've got always a corresponding hardware pool for a VM pool. And also these hardware pools can be bare metal for maybe big HANA databases, or act as a hypervisor pool. Most of the hypervisors we are using are Xen. It's about more than 90%, I guess. But it doesn't really matter. You can use KVM or VMware also. And then we've got the VM pools, and finally the virtual machine for the customer.
Yeah. To tell you a little bit more about how big this stuff really is that we are doing is, we have, as we said, 13 data centers around the world, operating 14,000 VMs in the HANA Enterprise Cloud. I can't really tell you about the applications because we are on the level down below. But they're running HANA, of course. They're running S4HANA, and they're running like all the SAP applications in there. To the 14,000 VMs, we have 900 hypervisors, as I said, mainly Xen, and we've also 1,700 bare metal installations, and these are mainly big HANA servers, several terabytes of RAM.
Well, I can top that. SAS is the older cloud and even the bigger cloud. So let's have a look. We've got 90 landscapes in 18 DCs, or 18 locations with partly several DCs. We've got more than 30,000 VMs. We've got almost 4,000 hypervisors, and also more than 1,000 bare metal installations, also mainly for HANA databases, the big ones.
Yeah, so let me tell you a little bit more about the Global Management Portal. It's an SAP internal development, so unfortunately it's not open source, you cannot buy it. But if you are a SAP customer, you can of course use it. And all the things that we are showing you next, we could also be done, I think, on like an OpenStack environment. So it's just the orchestration platform for almost everything at the SAP, so we're kind of bound with that. Yeah, you can look it up there. It does all the network orchestration you can imagine. It does all the hypervisor and VM deployments, and also configuration. we have our operating system images defined in there. This thing also does monitoring, and you can configure all other services you can imagine, like LDAP, storage. We even have a remote execution tool. And of course, auditing can also be done with it. So everything you're doing in the Global Management Portal is logged and kept for auditing.
Yeah, there's also is our customer front end. They can run self-services to deploy their environments. And we've got and it is an inventory database, which we make really heavily use of.
Yeah.
It's quite a central point for administration for us.
Yeah.
So now let's go to what we have done actually. First of all, the operating system images. The older way was just we are having a gold master VM, which is up and running. And when new updates come in, like be it security or any kind of patches or any changes that we had to do, we are doing it directly in the VM and then cleaning it up, dumping it with the script, and then restoring it for deployment. We also got different VMs for different types. We've got hypervisor VM images. We've got virtual machine images. And also we've got different images for every service pack for SLES 11. And I think that's mainly it. We've got also some Windows VMs. But that's not what we're talking about. But this brings us to some pitfalls. First of all, it's a waste of resources. Different image types, different service packs, or are running VMs that are mainly doing nothing. And also, dumping a running system is unclean. There are processes running. There are log files that have to be backed up maybe and put away because the customer doesn't want to see old log files. We've got a bash history that has to be cleaned up. And also, we've got no good version control or changelog. We manually write a changelog of the changes we are doing. And we've got no reproducible builds. If a build fails, or if it gets lost, the dump, and I want to re-dump it, I always get a different result than I had before. So finally, you do not really know what you are deploying.
Yeah. So let's skip that very fast.
Okay. Come on.
I'll show you how we're doing it now, kind of more in the fancy way. As I said before, we're making heavily use of the open build service already at SAP. So now, basically, we are building all the images the KIWI way in the open build service. Some of you may know KIWI.
Yeah, tell us a little bit about
it's basically it's a descriptive language in XML. So you can define an XML file and put all the things in there you need to create an image, like which partitions should be created on the VM, in which RPM packages are installed, and of course, which repositories are being used for that. So we are very flexible in doing that.
And also, we wanted to keep that images small to make the deployment even faster.
As I already said, we had this already integrated in the open build service. The whole build is way more cleaner than having these VMs running, as you can imagine. You can actually the content is actually very well defined, and the builds are very, very reproducible. KIWI is doing a great job in there. We also have introduced the release management because these KIWI files can be versioned, and we kept them in Git version control. So we could always go back and say, okay, I want to build the image I built 3 weeks ago, and then we just check it out, push it to the open build service, and it will build this for us. And deploying these images is way faster because they're smaller. They're about, I don't know, 400, 500 megabytes.
About 400.
They're now, and you can imagine a running VM is like 2 or 3 gigabits if you had run it for 5 years.
Well, actually, we clean it up. It's not that big, but it's more than a gig.
Yeah. And actually, one good point I wanted to say, we always have up-to-date packages, up-to-date images, because if somebody pushes new RPMs to a repository we're referencing in the KIWI files, KIWI automatically triggers a rebuild of the image, and we have already up-to-date packages.
Okay, so let's look how we deploy the images. First of all, we have a server. It simply does a pixie boot, then fetches the so-called blade installer, which does some basic configuration and restores the previously dumped image when it's fetched. Then it reboots the machine, and then our handwritten first boot script runs, which is written in Perl with some additional modules, and it's deploying config file templates, tells the system which daemons to run, start, stop, or what to do, and also does all the platform and DC-specific parameters, sets like NTP servers, DNS servers, LDAP servers, also for the pools. Then it reboots again, and finally the server is ready. This is quite nice, but yeah, also has some pitfalls. We've got all the data stored in files, and as I told you, SaaS Cloud is about 10 years old. The code grew and grew and grew. More landscapes were added, and it's becoming unmaintainable, kind of. It is still maintainable, but it's hard, especially when you're a new employee and getting to start to work there. Yeah. You really have to read lots of code and understand it. This is not that good. Also, we've got not real good version control or changelog. It's also manually written by the admin. And you got to rely on the admin that he exactly writes into the changelog what he has done.
Yeah, and because it's just a Perl script, you can't run it twice. Maybe you could run it twice, but it wouldn't do the same things.
Well, it would do the same things, but
actually append the file twice or things like that.
So no good reproducible builds.
Yeah. So it looks like kind of the same, I think. But the first thing we changed is we're using the KIWI images I introduced before. As I said, it's way more faster. Then, of course, the machine has to reboot it, and then we'll start Cloud Init. You may know it from OpenStack. It's the software for bootstrapping machines, I think, that's out there in the OpenStack. And we're only using it to get basic network settings done, like IP addresses and routes, and rewrite the Chef client settings. After the Chef client settings are written, we run the Chef client, and the Chef client does all the stuff that the first boot had done before, but in a way more better way, because it's a real configuration management tool. Yeah, it writes all the configuration files, starts, stops daemons, and writes all the platform-specific parameters. Then the machine reboots, and the machine is ready. As I said, it's way more cleaner. We have actually separation of data and logic because, Chef comes with that.
We'll show that later.
Yeah. Everything is kept in Git now, not in the old solution that we had. We have actually a great changelog in Git for this stuff, and it's way more maintainable. If a new person enters the company and he wants to learn how we are doing the deployment, he just had to know a little bit about Chef, and has to be introduced in a workflow, and then he can start. He didn't have to read these old Perl scripts. Yeah.
And also for us, who are quite common with the old versioning, it's easier for us too.
Yeah.
So let's have a closer look at Chef. So please introduce it.
Does anybody use Chef here? You? Okay. I won't tell you how Chef works, but I can tell you a few entities that there are in Chef. So first of all, we have a client-server architecture that we are making use of. The actual data in Chef is stored in an entity called attributes, which then are used in roles or cookbooks, can be grouped in roles or cookbooks. The actual execution of code is done in recipes, and recipes can be grouped into a thing called cookbooks, kind of the kitchen slang that's in there. See that? Then we have a dependency design in Chef that you can have roles. In these roles, as I said, there are the attributes defined for example, NTP servers for a specific data center and something like that. And then we can nest these roles, actually. So we can concatenate several roles and do all the dependency stuff you can imagine.
Yeah, we can also override before set attributes to a new version. For example, if a customer uses an own LDAP server or something.
I think we have an example of that later.
Okay.
Yeah. Yeah, and then we have the run list. That's the actual concatenated things that will be done on the client level. We also introduced the lifecycle release management with Chef, because there's something called Chef environments where you can basically say, okay, in my test environment, I want to run all the latest stuff, maybe the upstream cookbooks that we developed, and you can say in the production environment, I want to run the stable tested code. We have an example of that later, I think.
Yeah, we do. So let's have a last short look at the version control. Up to now, it was just a local SVN on the server, all the first boot scripts reside. And in fact, only first boot and some subdirectories are really under version control, but we had none for external sources. The pitfalls here are we've got no real AAA, authentication, authorization, and access control, which is kind of uncool. Also, we've got no QA workflow. Admin does the changes, checks them in, and they are live. Because no one's there to approve it or to check the quality of the code. We wanted to get rid of it, and we have done it with Git.
Yeah, as I said before, we are making use of the already deployed GitHub Enterprise at the SAP. We check in almost anything, I think everything.
I think everything.
Like KIWI files, all the Chef cookbooks in separate repositories because it makes it easier to test the code. Chef environments, of course, all our test suite that we have, unit tests, integration tests, and also all the Jenkins definitions that we have. We all check this in the GitHub. So yeah, even if our Jenkins server would die, we would already have that in version control and could, I think pretty fast set it up again.
Yeah, I think you all know Git quite well, and you know how to rely on it. And we already had it there anyway, so we're using it. And we also have now real authentication, authorization, and access control. And also our workflows we are keeping in Git.
Yeah. We're coming to the workflow now. It's actually my favorite part.
Yeah,
because it's the fancy CI part. First of all, we have the admin, of course. The admin is developing on his workstation, mainly the cookbooks that we are going to roll out on the systems. We packaged all the dependencies for cookbook testing in the open build service. These are mainly Ruby gems that we packaged with gem to RPM. So if the admin is running SUSE on his system, he's lucky because he can make use of that. He can run all the RSpec tests, all the cookbook tests on his workstation, as I said, even before checking it into the GitHub. If he commits it to GitHub, we have the Jenkins connected to the GitHub, and there is a Jenkins plugin called GitHub Organizations. It's the greatest plugin I've ever seen because it just scans the whole organization in your GitHub and looks for Jenkins files in it. And if he finds a Jenkins file, he automatically creates the jobs in Jenkins. So you don't have to do anything in Jenkins manually. You only have to put a Jenkins file in your GitHub repository and define in there how the code should be tested. So if the admin commits something to GitHub, there's a hook between GitHub and Jenkins, and Jenkins starts to build the code. First, it tests the code, and then it builds the code. And then it looks if it worked. And if it worked, there's a green hook in the GitHub, and another admin is able to merge the stuff. Yeah,
we've got still approval needed by another admin to be sure that the code really is good.
Yeah, and to test this stuff, as it said here, we have the ability to test all the stuff in Docker images. The Docker images look pretty much the same as the virtual machine images that would be deployed in production, but testing this whole stuff in Docker is way more faster, as you can imagine, than powering up a virtual machine.
Yeah, they're based on the same KIWI file.
Yeah.
And when every test is fine and the second admin approves, GMP fetches the new cookbooks and recipes from GitHub and deploys it to the chef servers or over the landscapes. Of course, only the related stuff for the chef server, so it doesn't fetch, it doesn't deploy wrong configurations the chef server doesn't use.
Yeah.
So how do all these new tools integrate into GMP? First, a reminder, we had that before the slide. So what is done in GMP? We've got an automated chef server installed. You just run the self-service and then the new chef server is installed. Then you can fetch all the recipes and cookbooks that are needed. We've got chef server tasks like manipulating node objects or also defining some definitions for pools. And we've got the whole configuration database and the mapping of entities, either be it images to pools, the chef servers a pool is using. We've got the attributes for landscapes and pools, and the final run list, what is actually done when a new VM or hypervisor is deployed. Also, all the sync automation between GMP, Git, and the chef servers is integrated now. And all those attributes, environments, cookbooks, and roles are fine integrated into GMP. So how does it look now? Yeah, I know it's hard to read on, on the. So let me talk a little about it. We've again got the admin, which is interacting with GMP. Then we've got the separation between SAS and HEC. And I think you can read that there's a single attribute. It's just set to make the differentiation between SAS and HEC. Next, we've got again our landscapes, which have some attribute roles where all the DNS, NTP, LDAP servers, and all those infrastructure-related stuff is stored. Again, we've got the resource pools. Nothing to do here in Chef as it is just a logical entity for us. And then again, we've got our hardware and VM pools. You see, there's a lot of orange in here. We've got a base role for each pool. We've got attributes in this role and maybe environment, if it's test or prod landscape or whatever. And then we've got a final run list, which is used for new deployments.
Yeah, to show you how this looks on the chef server and maybe you understand a little better then, please go forward. I have an actual example here. This is a JSON file that we would upload to the chef server, so it gets a little bit more, you know. First of all, you see that this is a landscape in here. It's named landscape SAS 01, like it says here. And then there we have an example for attributes that we would parse. Yeah, like for example, NTP servers or repository servers. So this is the actual data that is stored in a landscape object that we have in here, in the chef syntax. Yeah, forward, please. Then we have a base role. This entity here goes here. It just says VM base. So this base role is attached to every VM pool that we have out there, and then we can. This is kind of a nested thing, as I said before. That we can define. First of all, we can override attributes that we set one level above that in the landscape. So if a customer has a custom ADAP server, we can override it here. Yeah. So and we have the run list thing that we mentioned, and here's the actual doing defined that we run this recipe, this recipe, this recipe, and of course 20 other recipes. So if we want to reference, okay, I want to install a VM, we just have to reference, okay, the base role is VM base. We don't have to say, okay, install this, 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 this. We just have to say install the base role. Yeah.
Next one is the run list that is attached to the, in this case, VM pool. As you can see, we've just got a landscape role for the basic infrastructure, and we've got the role VM base. And of course, we can have additional roles, like for the customer, special settings and things. And that it fetches all the stuff that is in those roles. You can put in there additional recipes or additional attributes, and then it takes all this and configures the client accordingly.
Yeah. And here's an example of the environment I mentioned before, where we're defining which pools are actually production pools and which pools are actually test pools. Here is the environment, and this is an example of it. So this environment would be called VA landscape 01 prod.
This is a prod, yeah.
And there we would define, okay, we want to roll out these actual versions of the cookbooks that we tested before. In the testing landscape, or a development landscape, we wouldn't mention the cookbooks, it would just check out the latest code that we have. And in the test landscape, we would have some minor numbers higher here, I think.
Yeah. Also on the right side, you can see our two customers. They might have own chef servers, or might have chef servers especially for them to make some configuration only for that customer. Yeah. So let's go on and final conclusion. What have we done? We've cleaned up the deployment process. We've got rid of all those ancient Perl stuff and introduced chef and config management. We've implemented a way better testing and integration workflow with the whole continuous integration and continuous delivery stuff. Let's call it CI, CD, and DevOps. We've got almost identical infrastructure code for both clouds now, as we are using the same recipes, and the differentiation between the two clouds is just a single attribute. And we feel kind of future-proof with that approach. When a new version comes out, we test it, make maybe some little adaptations, and then it runs perfectly fine for SLES12, SP2, yeah. SP3.
SP2 is a good example. I tried it out, I don't know, with R33, I think. And yeah, okay, we had to change some upstream chef code to get it working because somebody changed the output of zipper info, I think. But okay, that was a regex I had to add there, and yeah, then the whole thing runs fine on SLES12, SP1, SLES12, SP2, and with nearly no changes, except of, okay, on SP2 I have to install a few other packages for.
Yeah, but that's really minor changes you can very easily do in Chef.
Yeah.
And yeah, if someone comes to the nasty idea to use Red Hat or something like that, we also can implement it. We just put in a switch in our recipes, and then we are fine for Red Hat too. Yeah. So we feel quite confident with it.
So what's to come? Actually, we have a first customer who's deploying applications the Chef style. He's writing his own cookbooks, has his own Chef server, and yeah, he's pretty doing fine with it. He's pretty fine with it.
He even uses it in production already.
Yeah.
Then we've got some beta customers, especially for HANA 2. They are also testing our SLES12 now. And as far as I know, they are quite confident too.
Yeah. We're going to backport some stuff to SLES11. We kind of want to try it out. We don't know if it will go to production, but
depends on the time. But yeah, we want to do that because SLES11 still runs on the first boot scripts, and we want to get rid of it also for SLES11. So we want to backport the whole deployment process and also the configuration management for SLES11.
Yeah. I think so. Yeah,
we are at the point. Thank you. First of all, we want to thank you for listening, but we need to thank some other guys who are working with us on this project. Those are the names. As you can see, there are quite a few teams involved. And without those guys, we wouldn't have come that far, I guess.
Yeah. So thanks to them.
So now we're done, and want to ask you if you have some questions for us.
I haven't played with KIWI or Open Build Service really at all. Mm-hmm. Y'all have like Ubuntu, Red Hat, and stuff on earlier slides. Do those fit in the KIWI and Open Build Service too, or like in your workflow, or do you have to redo that? Let's just say somebody says, "Oh, want to have Ubuntu 16.04. Well, the thing has changed.
Well, actually, OBS is capable of building packages for different distributions, but with KIWI, I'm not sure.
I'm not sure either. I think
really
Red Hat is possible,
tool.
isn't it? With KIWI? Yeah.
Yeah, they can play nice.
Yeah.
Ubuntu throws a monkey wrench and everything.
Yeah, but they have own tools to do that. So.
And then you guys do any of the UV stuff as opposed to the traditional Pixie boot and
Yeah, sure. This is done in the Blade installer. We've got a new version for UEFI too.
Yeah, actually, we have the first hardware now who only boots UEFI. Yeah, and we had kind of hassle with that, but
yeah, it's going to be a problem.
yeah, because they're using another Pixie mode, I think. Yeah, that's could be a hassle, but doesn't have anything to do with the configuration manager. It's a level below. It's the image deployment. We have custom written software for image deployment, which starts after the Pixie boot. It basically loads a SLES ISO, and then in the initID it calls a Perl or a Bash script to deploy all this stuff with the custom parameters. Yeah, that kind of stuff.
So, any other questions or remarks?
Yes.
Yeah.
I would like to say thank you, and I think you well deserved a round of applause for your presentation. That was really great.
Thanks. Well, thank you.
I wanted to say that what you are doing, we have a lot of similarities, and I mean, SUSE Custom Center team, so we do a lot of similar stuff, and I'm actually amazed that it seems like good ideas are just out there to pick up. So, like, you decided on your own how you will build the architecture, all of this is very similar to what we do, and it's very cool. That means like some serious people who are really working with massive deployments are really choosing this back. And it's great. And we're like, in comparison to what you do, we're like tiny thing. But we also have a lot of learning through this process, and my question, I have two questions. First one is about cookbooks. So you mentioned you're using upstream cookbooks.
Actually,
we have some from the supermarket, but most of them are custom written by us.
Yeah, because it's kind of a philosophy. You want to know which code you're running, and if you write the code yourself, then you know exactly what it does. Yeah. And you have to have a way to update these supermarket cookbooks. And this can kind of get hard, because it's also kind of an isolated environment. We don't have any internet access. That's why we build all these gems ourselves, for example. Yeah, and I think it would be quite hard to update these supermarket cookbooks. That's also important, yeah.
Right, I mean, there is just a beginner's level with the supermarket cookbooks, because you can give a try for certain things. But when you do a very tailored cookbook, it proves more useful because you fully understand what's happening there. You can tune it the way you like. And well, it's always good to contribute back to the open source, but sometimes it just doesn't make sense for the cause.
Yeah,
really, because it's quite a unique environment we are handling here.
And honestly, our self-written cookbooks are way more minimalistic than these things in the supermarket are, because we only have one operating system at the point of time, SUSE.
Yeah.
And yeah.
And the other question I had about what you mentioned about that you do testing in Docker, so you use Test Kitchen, right?
Yeah.
So you're using Docker container running, which has like exactly one process. How you do it? What do you use for the unit?
We actually use systemd.
It's a full-fledged system.
No, it's a Docker system, but it's I don't know the term for it. You can pass capabilities to Docker containers, and if you pass enough capabilities, I cannot name them, then you are able to run systemd in Docker containers.
How that works? Like it's working well for you?
Yeah.
Yeah, it does. We are building the Docker images with the same KIWI file as the VM images.
Yeah.
So that works.
Cool. Thanks.
Yeah.
So thanks again for listening. If there are no more questions, I think we can quit and show you maybe 2 talks that are still upcoming. SUSE wanted us to do, so maybe you have a look there too.
Cool.